Okay, so hello students. We are going to discuss the NEET 2025 Physics paper. Okay, so let's start. Question number 1. A parallel plate capacitor made of circular plates is being charged such that the surface charge density on its plates is increasing at a constant rate with time. The magnetic field arising due to displacement current is. So first of all, we should know the displacement current. The formula of this one is id equal to epsilon naught d by dt of phi e. Phi e stands for the electric flux. The value of phi e is E into A, and the field between the plates will be sigma by epsilon naught into A. So the thing is, the id will be equal to epsilon naught d by dt of phi. So we'll differentiate this one. So A by epsilon naught constant, d by dt is sigma. Now from here, we can cancel it out. So id A into d by dt of sigma. Now in the question it says that the charge density on its place is increasing at a constant rate. That means d sigma by dt is constant. So let's take it A into K. So that is the displacement current. Now we need to see the magnetic field. Okay, so this is the circular plates, and we know this is the displacement current which passes, which flows between the capacitor plates. Okay, that's how the displacement current is. So because of this displacement current id, there will be a magnetic field around it. So if we imagine a cylindrical surface containing the cross section area of the circular plates. So this is the shape of the cylindrical here, and this id through which it is passing. So let's assume this is a wire. So now the magnetic field due to wire, which is the formula is mu naught I by 2 pi. Let's say this distance, this will be the radius, right? So let's say that is r. Now this I is equal to id here. Now I'll put the value here. So magnetic field is mu naught by 2 pi r. id is A into d sigma by dt. Correct? Now what is A here? The cross section area of this one. 2 pi r into pi r square into d sigma by dt. Now from here you can say that except this r, that remaining all are constant. So we can say from here the magnetic field is directly proportional to capital R, and it will maximum on the surface of this cylindrical shape. So that the question option 1, non-zero everywhere with maximum at the imaginary cylindrical surface connected peripheries of the plate. So that is the correct option. So that is the question number 1. Let's move to the next question. This is question number 2. An electric dipole with dipole moment 5 into 10 to 1 6 coulomb is aligned with the direction of a uniform electric field of magnitude 4 into 10 to the power 5 Newton per coulomb. So first of all, the electric field, let's say, is in this direction, and the dipole is also in the same direction. So that's how the initial orientation is. Now we can write the initial potential energy here. So in potential energy formula is minus P E cos theta, so which is minus P E cos 0 to minus P E. Now the dipole is rotated through an angle of 60 degrees with respect to the electric field. That means this is the final position of the dipole. So it is rotated by 60 degrees. So now what is the final potential energy? So minus P E cos 60 to minus P E by 2. Now they're asking the change in potential energy. So change in potential energy is U final minus U initial. So minus PE by 2 minus of minus PE, which gives you PE by 2. Now put the values here. Delta U is equal to 1 by 2 into P, which is 5 into 10 to the power minus 6 into electric field is 4 into 10 to the power 5. So cancel here. So it will come as 1 joule. And that is the fourth option. So let's move to the next question. This question is a ball of mass The third question, a ball of mass 0.5 kg is dropped from a height of 40 meter. The ball hits the ground and rises to a height of 10 meter. The impulse imparted to the ball during its collision with the ground is. Okay, so let's start. So the ball is released from a height of 40 meter. Okay, so the ball will hit the ground with some velocity, let's say that is v initial, and it rebounds with certain velocity v final and goes up to a height of 10 meter. Now with these two heights we can find the initial and the final velocities. Okay, so first of all, the impulse, I'll tell you about the impulse. So impulse is nothing but the change in momentum only. Okay, so m into delta v. Okay, and we apply the impulse formula only when we see that the contact time is very less. So here you can see the collision time is very less, so we can apply the impulse concept here. So what you need to find is the change in velocity. So let's start here. So v initial, so initial velocity will be, like we can see, it will be root 2 gh. So 2 into 9.8 into height is 40, which makes it 28 meter per second, and v final is equal to root 2 g h dash, because this time that the h dash is different, and that is 10. Okay, so that makes it 14 meter per second. Clear? Now once we have this velocities here, now we can find the impulse. So mass is 0.5 kg into rate of the change in momentum. So change in momentum is 14 minus 28. So it is 1 by 2 into minus 14, so it's coming as minus 7 Newton second. Okay, negative is coming because of its direction only, but anyway we need to find that magnitude here, so the option 4 is the answer. Okay, let's move to the next question. So this is question number 4. The intensity of transmitted light when a Polaroid sheet placed between two crossed Polaroids at 22.5 degree from the polarization axis of one of the Polaroid. I know is the intensity of polarized light after passing through the first Polaroid. Okay, so here there are two Polaroid sheets already placed, okay, in crossed form. So if I try to draw the diagram, so this is the first sheet here, and the another one is the crossed one. Okay, so it's somewhat like this. That means the angle between these two is 90 degree, that we can see, right? Now between these two sheets there is another sheet placed, okay, placed between two crosses at 22.5 degree. So let's say this sheet is placed somewhat like this. Okay, this angle is 22.5 degree and the other angle will be 90 minus 22.5, right? Because you can see here from the diagram. Okay, so now we'll apply the Malus law to find the intensity. So I is equal to, so this is the intensity which is coming out, okay, that I1, right? And after this one we'll be getting that I2. Okay, I naught is the entering, that is given. I naught is the intensity of polarized light after passing through the first Polaroid. Okay, clear? So I naught is the intensity incident on this one, I1 is this one, okay, and this I1 will incident on this one, and this is I2. Okay, that's what it is, right, according to the question. Okay, now I1 is equal to, so the law of Malus, what is it? So I1 equal to I naught cos square 22.5, right? That was the law. Cos square theta, the theta is the angle between the Polaroid sheets. So here it is 22.5. The first equation. Now if I write the I2 here, now for I2 the I1 will be the incident. So I1 cos square, this time the angle is 90 minus 22.5. Is it clear? So I2 is equal to I1 sine square 22.5. That's what it is. Now we need to find I2, the final intensity. So we'll put the value of I1 here. So now we'll get I naught cos square 22.5 sine square 22.5. Okay, here we'll apply the formula of the relation between cos, how to double the angle. So here the cos square theta, okay, I'll write here cos square theta is 1 plus cos 2 theta by 2. Sine square theta is 1 minus cos 2 theta by 2. Okay, so I'm going to use these formulas. So theta is 22.5, so 2 theta will be 45. So 1 plus cos 45 by 2, 1 minus cos 45 by 2. So I2 is equal to I naught into, so it is root 2 plus 1 by 2 root 2 times root 2 minus 1 by 2 root 2. Okay, so that numerator becomes 1 here and denominator becomes 8. So it is I naught by 8. Okay, and that is option number 1. So I hope it is clear. Let's move to the next question. Okay, so this is question number 5. The kinetic energy of two similar cars A and B are 100 and 225 joule respectively. On applying brakes, car A stops after 1000 meter and car B stops after 1500 meter. FA, FB are the force applied by the brakes on the car A and B, respectively the full ratio of FA to FB. So here we have the energies of the cars. So kinetic energy of A car is 100 joule and kinetic energy of B is 225 joule, right? And the car A stops after applying brakes. So we can see here the final velocity is going to be 0. So this is kinetic energy which will become 0. So from work energy theorem we can say, from work energy theorem, the work done by the force is equal to change in kinetic energy. Okay, so if we apply for the car A, so car A, the work done by the force is equal to Ka. Okay, the final minus initial and the force will be in opposite direction to the displacement. So minus sign will come, but we can neglect at this moment. Okay, if you want to write, you can write. Minus will be cancelled anyway, but this will come. Okay, and so work done by the force will be Fa into dA is equal to Ka, right? So that is the first equation. Similarly for car B, Fb dB is equal to Kb. That is equation 2. Now if you divide them, so Fa by Fb, okay, dA is the stopping distance, is 1000 by 1500 is equal to 100 by 225. 15 1 is 15, 15, 15 is 225. 1 0 0 cancel, so it's coming as 2 by 3. So Fa by Fb is equal to 2 by 3. Okay, and that is the fourth option. So I hope it is clear. Let's move to the next question. Okay, let's see the next question, question number 6. Okay, in this question the options were missing, so I just wrote the options here now. So in this question, we need to find the current passing through the battery in the given circuit. So the total current we need to find. For that we need to find the equivalent resistance. So you can see in the diagram, these two are in series. Okay, so our equivalent of these two will be 7 ohm. Okay, now if you see this A, B, C, D, E, F, this setup, okay, so you'll see that this is nothing but a Wheatstone bridge. Okay, means you can see here the 3 by 1.5 is equal to 5 by 2.5, which makes 2 only. That means this is a Wheatstone bridge. So in Wheatstone bridge, what happens? The middle center resistance is removed. Okay, so we'll remove the AD. So now we have, I'll just draw one equivalent diagram, B and this E. So from B, C, D, E, these 2.5 and 1.5 will come in series, right? And meets it 2, 3, 4. Okay, now from B, A, F, E, okay, this side, 5 and 3 are in series, which makes 8. And here we have 7, and this side we have 1 by 3 and then battery. Okay, so this is kind of an equivalent diagram. Now this 8 and 4 are in parallel, so it will become 32 by 12. Okay, so 32 by 12, so I'll draw one more diagram. So from between B and E, okay, this is B, this is E, so 32 by 12, which makes 8 by 3. Okay, and then we have 7, 1 by 3 and then battery. Now you can see here this all 3 resistors, okay, are in series now. So R equivalent is 8 by 3 plus 1 by 3 plus 7. which makes it 9 by 3, 3 only, 3 plus 7 equal to 10 ohm. So I is equal to 5 by 10, which is 1 by 2.5 ampere. That's it. So this is the option D. Okay, so that's about the sixth question. Okay, let's move to the next question. Okay, so question number 7 is based on the heat transfer. Three identical heat conducting rods are connected in series as shown in the figure. The rods on the sides have thermal conductivity 2K, while that in the middle has thermal conductivity K. The left end of the combination is maintained at 3T temperature, and this one is at T. The rods are thermally insulated from outside. In steady state temperature, the left junction is T1 and the right is T2. What is the ratio? Okay, so what you can do is like you can replace these like thing, okay, with the resistors. Okay, there's like a kind of approach you can use. There is one resistor, another resistor, another resistor. Here the temperature is 3T, here T. The resistance of this one, the formula of resistance is L by Ka. Okay, in terms of conductivity, all are identical, so L and A are gonna be same. So L by 2Ka, L by Ka, and L by 2Ka. Now all are in series, so we can find R equivalent first. So R equivalent you can see here, it is gonna be 2L by K. So now what is the current then? So 3T minus T. Okay, 3T minus T divided by R equivalent. So 2T by 2L by K, 2 to cancel here. So TKA by L. So that is the current which is flowing from this end to that end. Now we need to find the T1 and T2. So T1 is here, T2 is here. Okay. Now you can simply find it out. If you see the first resistor, so the temperature difference is 3T minus T1 is equal to I TKA by L into R equivalent, which is 2L by K. Let's cancel here. So 2T. So 3T minus T1 equal to 2T. T1 is equal to T. Okay. So that is the T1 we have here. Okay. Then okay, just one second, there's a mistake I guess. Here put R equivalent, sorry, my mistake is like we are like taking the temperature difference across this one, right? So 3T minus T1 equal to I into R1, sorry. So KAL, so 3T minus T1 equal to T by 2, so T1 will come as 5T by 2, yeah, that is T1, okay? Now the next is like you can take the last resistor, so T2 minus T equal to TKA by L into the resistance, L by 2Ka. Again we will get T by 2, so T2 is equal to T by 2 plus 3T by 2. So this is T1, this is T2. Now you take the ratio, T1 by T2 is 5 by 3. So that's it. So this is option 1 is the answer. Move to the next question. Okay, question number 8, which is based on the oscillation and kind of like the damped oscillation, because the amplitude is going to be changing here. In an oscillating spring mass system, a spring is connected to a box filled with sand. As the box oscillates, the sand leads slowly out of the box vertically, so that the average frequency and average amplitude of the system changes with time. So we need to see the graph. So first of all, like the frequency, which we know is like root over K by M. Okay, the K is constant because it like depends upon the spring here, but you can see here that mass, it is inversely proportional to root over mass. Okay, like if you want to get a relation, so it is like kind of okay, just one second. So K equal to M omega square. Okay, so that's how we can say the omega square is inversely proportional to M. So you can see here like as mass decreases, okay, because it is decreasing, the sand leads slowly, so omega will increase. So okay, so that's how it is, like the omega should increase first of all. Second, amplitude, we know that amplitude, when there's a change in amplitude, okay, so from that damped oscillation, so it decreases exponentially. A equal to A naught e to power minus T BT, right, somewhat it is BT by M, right? So that's how it is decreasing. So we can see like from here that it is exponential decreasing, and this one is increasing here because that omega is right. So these two things, like omega is increasing and amplitude is decreasing, that is there in fourth option only. Okay, so that's how we can do here. Okay, let's move to the next question. Okay, next question number 9 is like on electromagnetic induction. AB is a part of an electric circuit. The potential difference between Vn minus Vb at the instant when the current is I is increasing at the rate of this. So we'll write Va minus Vb. So from this point to this point we'll move, and I hope you all know like how to move from one point to another point. So let's write the equation. So Va minus L di by dt. First we have inductor, then battery, then resistor I into R is equal to Vb. So Va minus Vb is, so all will go to that side, L di by dt plus 5 plus IR. Now I'll put the value here. L is given 1 and di by dt is again 1 because it is increasing, so positive only, plus 5 plus I into R, which is 2 into 2. So 1 plus 5 plus 9, which makes 10. So 10 volt answer. So option 2 is correct one. Let's move to the next. Okay, question number 10 is based on the modern physics. Here the Bohr's model we have. So there's a particle mass m is revolving around the origin with a constant force F pulling it towards the origin. So that means that F we can write as mv square by r. That will be the centripetal force. And here we have to apply Bohr's model. So that means mv are equal to nh by 2 pi. That also we can write. Now just need to substitute and let's get a relation. So v square is equal to f r by m. Okay, f is constant here. Now we'll put this v value from here, nh by 2 pi mr. So this value we'll put here. So n square h square by 4 pi square m square r square equal to. So you can see here that rest all are constant, so we just focus on the variables. So r cube is directly proportional to n square. So r is directly proportional to n to power 2 by 3. And from here we can say this one, that v is directly proportional to n by r. So directly proportional to n by n to power 2 by 3, which means v to power n to power v is directly proportional to n to power 1 by 3. Okay, so that is the relation r versus n and v versus n, and that option 1 is the correct one. Okay, so let's move to the next question. Okay, so question number 11, which is like you can see based on the kinematics here. In some appropriate units, time t and position x is given by this relation, the acceleration of the particle. Okay, so here you can see here like I just like solved this already here. Okay, anyway I'll do it again here. Just dt is equal to, okay, just 1 second. I was just checking the answer. Okay, yeah, so t is equal to h square plus h we have. Okay, we need to find the acceleration. So what we'll do here, first we'll differentiate this equation like an implicit function. So 2h dx plus dx. Now from here we'll find that dx by dt. So dx will by dt will be equal to, it will come as 1 plus 2h. Okay, now this is the velocity. Now v as a function of h we have, the acceleration is v dv by dx. Everyone knows this relation. So 1 by 1 plus 2h, dv by dx is minus 1 plus 2h whole square, then 2. So that makes the answer here, so minus 2 by 1 plus 2h ka whole cube, and that is the option number 4. Okay, so I hope you understood. Let's move to the next question. Question number 12, which is again like based on the modern physics here. The question says that an electron, which is like in a uniform magnetic field, states that the flux passing through the orbit of the electron is this one. So this is a like hypothetical model here. So the flux passing through that orbit, okay, orbit of the electron, so which is phi equal to nh by e, and the formula of flux, the magnetic flux is b into a. So from here like nh by e is equal to b into pi r square. And right, so yeah, and we see that according to the model, the magnetic moment of an electron in its lowest energy state. So lowest energy state means the n value is 1. So we can just put here n equal to 1, and we'll just like see that what is the ratio of h to e, so which is like b pi r square. Now we need to find the magnetic moment. Okay, the magnetic moment of an electron is evr by 2. So I hope you know the formula. So I'm just going to use this formula here into v into r. There's one more thing which you need to apply here, that force on the, now the electron is moving in a circle. Okay, so the force acting on the electron, magnetic force, will be like evb, right, and that is equal to mv square by r, right, because of the magnetic field only it is moving in a circle, right. V cancel here, so v by r is equal to eb by m. So I'll just put the v value from here to here in this equation. So magnetic moment is e by 2 into v is eb r square by m. So this magnetic moment will come as e square b r square by 2m. And now we'll substitute this r square, because in the options there is no r square here. So e square b by 2m, and r square is r square from here, e b pi equal to r square. So I'll use this one. So h by e b pi. B cancel here, 1 e1 is cancelled. Now the magnetic moment is h e by 2 pi m. Okay, and that is the option number 4. So that's the answer. So I hope you understood. Let's move to the next question. Okay, so next question number 13, which is based on the like optical instruments. A microscope has an objective focal length 2 cm eyepiece. So let's write the variable. FO is given 2 cm, FE is 4 cm, and the tube length L is equal to 40 cm. If the distance of distant vision of eye D is equal to 25 cm. Now they're asking magnification. I feel like there should be some more clarity, okay, because like the magnification formula of a compound microscope is V naught by U naught into D by UE. Okay, that is the formula of the magnification, the generalized formula. But from here, like if we use this VO and U values here, so we'll not get the answer. Okay, as per the options, because all the options are in like natural number only. So now the point is like here we use one condition. Okay, the condition is that the UO is at focal length. Means the object is placed at focal length, so we know that the image will be formed at L. Okay, on the that rays will become parallel and they will hit the eyepiece. So we can say that the image will form at length of the tube. So these two substitution we'll have to do there, and final image at infinity, that is another like case which you need to assume here. Then only like the magnification formula is L by FO into D by FE. So this is the formula which we are going to use here. So L is, everything is given, 40 by 2 into 25 by 4. So which means is 250 by 2, which is like 125. So that is the magnification, that is the answer. So hope you understood. Let's move to the next question. Our next question, question number 14, which is based on the friction here. It says that there are two inclined surface, inclination is 45 degree, which is same. One of them is rough, one is smooth. A given body takes 2 times as much time to slide down on the rough surface. Okay, so here we can see so here it says that the time taken by the body on the smooth surface, okay, on the smooth surface is half of the time taken by the friction on half of the time taken on the friction surface. Okay, yeah, TF is equal to 2 times TS. So let's just use the equation here. So same incline to same distance. So for the smooth surface, let's say the length of the incline is D, so is equal to half, it is smooth here, so GTS square. And if it is rough, so we know the friction will be acting, and that means, sorry, one second, g sine 45 है ना, the acceleration along the incline. G sine 45 means g by root 2 t square, and here when there is a friction, so g sine theta minus mu g cos theta, that is the acceleration, right? So g by root 2 minus mu g by root 2 into tf square. So we are going to equate these two. So if we equate them, so we can see that 1 by 2 t d sub, these all are cancelled. So g by root 2 ts square is equal to g, if it g by root 2 if I take common, the 1 minus mu into 4 ts square. So g by root 2 cancel, t square cancel, 1 minus mu is equal to 1 by 4, mu is equal to 3 by 4, meets 0.75 value. So option 2 is the correct answer. Hope you understood. Let's move to the next question. Okay, next question number 15. A full wave rectifier circuit with diodes D1, D2. If input supply is this one, then what is the value? So the question is on the semiconductors chapter. Okay, full wave rectifier, I hope you know full wave rectifier, okay, which remains positive in half cycle and then it changes its direction in the next half cycle, becomes negative, let's say. So if so we just need to find, because for the particular time we need to find out which one is forward and which one is reversed. So here, so the time interval we need to find here, the time period basically. So we can see that omega is given as 100 pi. So what is the time period? 2 pi by omega, which is 2 pi by 100 pi, makes 0.02, and the time given is 0.015. So we can see that the fraction is 15 by 0.02, which is nothing but 3 by 4. So this is 3 t by 4. Okay, so the time interval goes like this: t equal to 0, to t equal to t by 2, then t equal to t. So in this one, this cycle remains positive, in this cycle remains negative. The direction is changed. So if I say that in that 0 to t by 2, if it is positive, this is negative, then d1 is forward biased, d2 is reverse biased. But the time is 3t by 4, which means in this interval. That means this is negative, this is positive. So now this d1 is reverse bias, d2 is forward bias, and that is the answer. So we'll just check. D1 is reverse bias, D2 is forward bias. So question number 4, option 4 is correct one. Okay, D2 is forward bias, D1 is reverse. Yeah, correct. So hope you understood. Let's move to the next. Okay, question number 16, again on friction. So it says that there's a ladder, a rod, okay, which is lean against the smooth wall. So this side is smooth here, and this side we have a rough. Okay, now we'll just it is at rest here, so we'll just draw the FBD here. So these are the N1 normal here we have N2. This is rough, it has tendency to move in this direction, so the friction will be at in this direction, F1. Other than this one we have NG. That's it. And this angle is given, it says that this against a smooth vertical okay, this angle is 60 degree, that means this angle is 30 degree. Now first of all we can find the relation between them. In this circle part, if we write tan 30, which is nothing but N1 by F1, okay, from the vectors. So F1 is equal to root 3 times N1. Okay, so that's what we have now, and F1 we can write as mu N1, that's the formula. So from here we can find the friction coefficient, which is root 3. Now let's see if we can use it. Now we need to balance the forces. Okay, you can see here the upward force N1 equal to mg equal to downward. So N1 is equal to 200, is m is 20 kg. That's it. Now we just put the value of F1, which you need to find the friction exerted by the floor on the rod. So F1 we need to find the mu, which is mu N1 only. So mu is root 3, N1 is 200. So answer is 200 root 3. So option 2 is correct. So hope you understood. Let's move to the next question. Next question, question number 17, which is based on electrostatics conductors property. Two identical charge conducting spheres A and B both have same charges Q and Q. Okay, there's another body C, okay, which is neutral. Now what will happen, and that in the question they say is that the C is touched with A first, and then it is touched with B, then it is removed, and then again we need to see the forces between A and B. So initial forces is given that it's separated by certain distance, let's say R. So initial force between them is KQ square by R square. That is the initial force. Now we bring the body C touched with A. So what happens, like they are identical, all are identical in size. So A and C, when A and C are touched with each other, so Q charge is there. So what will happen, Q by 2 will be distributed. Okay, now this C is touched with B. Now when it's touched with B, the C is already charged with Q by 2, and this is Q. Now again half of the total charge will be like there on each sphere. So Q by 2 plus Q, 3Q by 2. So half of 3Q by 2 is 3Q by 4, 3Q by 4. So the final distribution will be on this one Q by 2, on B will be 3Q by 4, and C body is removed. Now again they are placed at the same distance. Now the force F dash is KQ 3Q square by 8 by R square. Now this is the equation 2. Now we just divide these two and find the F dash value. The F dash by F will come as 3 by 8. So F dash equal to 3 by 8 F. Okay, and that is the option number 2. That's the answer. Hope you understood. Move to the next question. Two cities X and Y are connected by a regular bus service X and Y. There's a girl, okay, which is moving with a scooty with 60 km per hour. She notices that the bus is going too wide, that a bus goes past of every 30 minutes in the direction of her motion. That means there's a bus which is moving in the direction of her motion, okay, in every 30 minutes. Okay, let's say that the speed is V, and there another thing, like she notices that every 10 minutes in the opposite direction. That means again she sees the bus, okay, in opposite direction in 10 minutes, okay, in every 10 minutes. Now the point is, like we just need to find the time period, okay, of the bus service and the speed consumed constant of the, okay, speed is constant, so this is also moving with V. Now according to the scooty, according to the girl, both will have same time period. Sorry, both will have like speed is same, right? So what we can say now, according to her, we'll see like the time periods are different. So if we see this bus which is going this direction, so according to her, the time period of this bus which is going the same direction is 30 minutes. So according to her, the speed of the bus is V minus 60. So speed equal to distance is going to be same, x to y only they are going by time period which is 30 minutes. Okay, this is according to the girl. The speed of the bus is V minus 60 d by 30 minutes. This is the time period. Now same thing will apply here. So according to the girl, what is the speed of this bus? So it is V plus 60, speed again same, and what is the time period? 10. So we'll just like divide them and solve it. V minus 60, V plus 60, 1 by 3, cross multiply, 3V minus 180 is equal to V plus 60, 2V equal to 240, V is equal to 120 km per hour. So that is in the option 2 only, and you can find the time period also, okay, from this one, 120 km per hour. So for the bus, the speed of the bus is 120 km per hour. Okay, we'll just find this distance also, like just put this V value here. So 120 minus 60, 60 is equal to d by 30. So d is coming as 1800 kilometer. So 1800 kilometer distance hai, this is the speed, so we can find the time now. So time is equal to distance upon speed. So when we solve this one, we get 15 minute. Okay, kilometer per minute, the unit we can say. So the unit, just let me check first, wait just 1 second. V is coming as like 120 kilometer per hour, that is fine. Okay, I'll just check 1 second. 60 kilometer per hour, there's a speed d by 30 minutes. Okay, so here we are writing in minutes here. So minutes can be written as like 1 by 60 hour. Okay, so now hour cancelled. So d is coming as it is coming as how much is it, 30 kilometer. Okay, so 30 kilometer is the distance, fine. So 30 kilometer is the distance. Now this time is equal to distance 30 kilometer upon speed, kilometer per hour, which is coming as like 1 by 4 hour. So that is again like 15 minutes. Yeah, the option is 2 only, but that because we got the speed and there's only one option where we have speed 120 kilometer. So directly also we can do, but in case if you want to calculate the time, so that's how it is. So option 2 is correct one. Okay, so hope you understood. Let's move to the next question. Okay, question number 19 is like based on the thermodynamics here. A container has two chambers of volume V1, V2 separated by partition made of a thermal insulator. So this is conductor made by this partition here. So P1 V1 temperature is T here, P2 V2 temperature is T. When the partition is removed, the mixture attains an equilibrium pressure here. So here we just like take this assumption here that the temperature, okay, this mixing and all is all happening at the constant temperature. So once we do this one, so we can apply this conservation of moles here, right? So what we can say that N1 plus N2 is equal to N, the mix. So N1 is P1 V1 by R T1 plus P2 V2 by R T2. T1 and T2 are same, is equal to P, this is the equilibrium pressure, V1 plus V2 divided by R T. N1 and N2 values are directly given, so we can just put the value also 5 plus 4. No need to put this values here. Pressure P into V1 plus V2 is 5 divided by R into T. Okay. Then if we put the value here, then we need to substitute this RT also. So let's do one thing. Let's say RT cancel. Let's cancel it, and we'll put the P1 V1 value. No worries. So P1 V1 will be coming as 1 into 2 plus 2 into 3. Okay. So what is it now? So 2 plus 6 is equal to 5P. Okay. So it is coming as P equal to 8 by 5. 8 by 5 is 1.680. So that is the answer, like the pressure at equilibrium. Okay, pressure of the mixture at equilibrium. So the option 4 is correct. So hope you understood. Let's move to the next question. Question number 20, again based on the modern physics. The Broglie wavelength of an electron orbiting in the n equal to 2 state of hydrogen is close to. So lambda of that electron is h by mv. Right, and we need to apply the Bohr's model also. So we can say that mv are equal to nh by 2 pi. The n value is given 2, so we'll just put here, cancel it. So mv is equal to h by pi r. So let's just put the value here. So h by pi r. So lambda is coming as pi into r. Now r is the radius of the second orbit when n equal to 2. Up here we know that r is directly proportional to n square from the Bohr's model. So r2 by r1 will be n2 square by 1 square. So r2 will be 4r1 and r1 is given, the Bohr radius. So lambda is equal to 3.14 into 4 times 0.052 nanometer. So when you solve this one, you'll get almost 0.67 nanometer, I think. Okay, so you can do your calculation. Okay, and this is the fourth option. So this is the answer. Okay, so hope you understood. Let's move to the next question now. Okay, next question, question number 21, which is on AC chapter. To an AC power supply, 220 volt, 50 hertz, resistor R is equal to 20 ohm, HC is given as 25 ohm, capacitance reactance, and the inductive reactance is 45 ohm. They are connected in series. So first we need to find the corresponding current in the circuit and the phase angle between the current and the voltages. So we know that the vector diagram here. So this is R, this is HL, this is HC. So first to find the current, we need to find the impedance, the Z. The Z formula is root over R square plus HL minus HC whole square. So Z comes as 20 square plus 45 minus 25, sorry. So which is like 20 only. So it is 20 root 2 ohm. Okay. So this is the impedance here. Now we'll find the current IRMS, which is VRMS upon Z. VRMS 220 by 20 root 2 makes 11 by root 2 ampere. Okay, now like the resolved diagram is this one, HZ minus H. Now the resultant will be this one, and this is the phase angle, the phi. So tan phi we can find the phase angle between the voltage and the current. Okay, so that is phi. So tan phi is HL minus HC by R. HL minus HC is 20 by 21. So phi is coming as 45 degree. Okay, now we need to find the current here. So current already we did, sorry. The current is 11 by root 2 ampere. Now if we just solve it to the corresponding in the circuit, right? So I RMS. So if you solve it 11 by root 2, so this will like almost comes as 7.8 ampere. Okay, it will come like that. So 7.8 ampere is the current, and the phase angle is 45 degrees. So that is the fourth option, which is correct. Okay, so hope you understood. Move to the next question. Okay, next question, which is based on the photoelectric experiment. It is asking like the relation between photoelectric current and the property of light shown on the axis. So first, photoelectric current intensity. So this everyone knows that this is correct. It's like direct question from the textbook. Okay, we know like when the intensity increases, the number of photons will increase. So more number of electrons will be coming out. So that's that current increases. So it is directly proportional to this one. Now that second, the property of the light is given as frequency. Frequency exactly does not affect the photoelectric current. Because frequency, we know that frequency is somehow is related with the energy of photon. So if current at a certain frequency, if current is like suppose 5 ampere, so if you increase the frequency, so that in that case also the current will be 5 ampere. So frequency does not affect the current. So frequency affect the energy of photon, energy of electron. Okay, and that's where we introduce the stopping potential in the experiment, but here we don't need to consider that. So frequency, so the photoelectric current does not depend upon the frequency. Okay, so that is why the first option is correct. So option 3A only. So hope you understood this one. Move to the next question. Okay, this question number 23 sorry, which is like from the sound wave, okay, the organ pipes topic. So it says that the pipe open at both ends has a fundamental frequency. So open at both ends, so the fundamental frequency F, which is equal to L, so lambda by 2 equal to L, so V by 2L. That is a frequency which we get in the air. Now it is dipped vertically in water drum to half of its length. So when it is submerged in water, half of its length, so that means it becomes a closed pipe, and this now the fundamental frequency. So L by 2 will be equal to lambda by 4. So lambda equal to 12. So again, if you calculate the frequency V by drum in V by 12. So that means the fundamental frequency earlier V by 12, still it is V by 12. That means there is no change. So we can say the fourth option is correct. Okay, so hope you understood. Move to the next question. Okay, question number 24, which is based on the oscillation SHM. Two springs K1, K2 oscillates vertically if their maximum speeds are same. Maximum speed formula V omega, which means V P omega P is equal to VQ. Sorry, maximum speed is omega A, है ना? तो omega P AP is equal to omega Q AQ. Okay, so that's what we are going to do now. So AQ by AP is omega P by omega Q, and we know like omega is directly proportional to root over K if mass is constant. So it says that two identical point masses. So we don't need to consider the masses here. So it becomes Kp by Kq, and as according to the question, Kp is K1 and it is K2. So AQ by AP is equal to root over K1 by K2, and that is option number 2. So hope you understood. Move to the next question. Okay, this question number 25 is based on the logic gates from semiconductor chapter. Okay, we need to find the output, and based on the output we need to decide the gate. Means like this given gate is a resemble of what gate. So let's try to solve it. So here that input is A, here the input is B, here B, here A. So this is a NOR gate which will give you A plus B bar, and this is NAND gate, so which will give you A B bar. Now these are the inputs. Now Y. So Y I'll write as A plus B bar, and this is a AND gate, है ना? So dot A bar dot B bar. Sorry, wait, this is a whole bar, right? Whole bar है, ठीक है. Okay, now just to solve this one, we use the De Morgan's law. Okay, what is the De Morgan's law? A plus B whole bar is equal to A bar dot B bar, and A B bar dot is equal to A bar plus B bar. So let's use it. So I'll just put the value of A plus B whole bar is A bar dot B bar into, and this one is written as A bar plus B bar. Now just multiply it, open the bracket, A bar dot A bar B bar plus A bar B bar dot B bar. Now A bar dot A bar is nothing but A bar only. A bar B bar plus A bar B bar, and this is again A bar B bar, A plus A, है ना? A plus A is equal to A only. Now A bar B bar can be written as A plus B whole bar, and this is the NOR gate. So option 2 is the correct answer. So hope you understood. Move to the next question. Okay, next question number 26, based on the thermodynamics here. An oxygen cylinder of volume 30 liter has 18.20 moles of oxygen. After some oxygen is withdrawn from the cylinder, its gauge pressure drops to 11 atmosphere pressure. So first of all, like we should know the total pressure, like absolute pressure we write as atmosphere pressure plus gauge pressure. Okay, so that is the formula we should know here, that we can use here. At temperature 27 degrees Celsius, right? The temperature is 27 degrees Celsius. So first of all, let's see what do we have here. The volume is 30 liter, okay, which is nothing but 30 into 10 to the power minus 3 meter cube. And what do we have here? The pressure will be atmosphere plus gauge pressure. So atmosphere pressure can be considered as a 1, let's say. So 1 plus 11, so 12 atm. Yeah, 12 into 10 to the power 5 Newton per meter square. Okay. Okay. I think like there's some unit error here, Newton per meter. Okay, fine. And we the number of moles, okay, which you need to find. So in this case, like once we are going to calculate the final number of moles, okay. So n equal to PV by RT. Here volume remains constant, the oxygen cylinder of volume 30. So cylinder volume is not changing. Okay, initial volume 30, final volume 30. We are just going to find that final volume, the final number of moles left in the cylinder. Okay, so n equal to PV by RT. So P is 12 into 10 to power 5 into 30 into 10 to power minus 3 divided by R is given as 100 by 12 into temperature is 300. So just we'll solve it and we'll get the value 14.544 moles. Okay, you can do this calculation. Now number of moles is this one. Now we'll see the number of moles those went outside. Okay, so initial number of moles 18.2, final is this one, so delta n. 18.2 minus 14.544, which makes 3.66 moles. So 3.66 moles were gone, okay, from the cylinder. Now we need to find that mass of the oxygen withdrawn. So from this mole we'll calculate the mass. So mass is equal to 3.66 into the molecular mass is 32 gram by 1000 to convert into kilogram. Okay, so number of moles into molecular mass, we'll get the total mass, and when we solve this one, we'll get the value. The value will be like, if we solve it, is equal to 0.116 kg. So that's option 1 is the answer. So hope you understood here. Move to the next question. Okay, question number 27. Certain camera combination of 4 similar thin convex lenses arranged axially in contact, the power of combination and the total magnification compressed into the power and magnitude for each lens. So we know the combination, the 1 by f equal to 1 by f1 plus 1 by f2 plus and so on. The power we need to find, so which is p1 plus p2 plus p3 plus p4. All have same power, so the equivalent power will be 4p. Okay. So the power is 4p. Now magnification, the total angular magnification which we write is m1 into m2 into m3 into m4. So what is that? M to power 4. Okay, so that is the magnification formula. No? This is the formula which we use when we need to find the the net magnification due to combination of lenses, 2 lenses, 3 lenses. This one like normally we use in optical instruments. No? So anyway, so this is the magnification, the net magnification, this is the power. So option 1 is the correct one. So hope you understood. Let's move to the next question. Okay, question number 28, based on the thermodynamics now. It says that the 2 gases A and B are filled at the same pressure in separate cylinder with movable piston of radius RA and RB respectively, on supplying equal amount of heat. Okay, this is important, to both the system reversibly under constant pressure. The piston moves by the 69 if the change in the energy is same. So from the first law of thermodynamics, so delta Q is equal to du plus delta W. This is same, this is also same, so that means W1 equal to delta W2. Now if this is same and the constant pressure hai, so that means delta V1 equal to delta V2. If pressure is same, so constant will be cancelled out. Now the change in volume, you just need to equate them. So change in volume in this first one, pi RA square into HA is equal to pi RB square into HB. So pi cancel here, so RA by RB is equal to, that we need to find is HB by HA square root. Okay, RA by RB is HB by HA root. Now what is HB? Is the displaced 9 by 16, so this is 3 by 4. So RA by RB is 3 by 4. So that's option 4th. So hope it is clear. Let's move to the next question. Okay, question number 29, which is on the fluid mechanics. Okay, it says that the balloon is made of a material of surface tension as inflation outlet from where the gas is filled in as a small area. So there's a balloon here. Its area is capital A, and its radius is capital R here. Density is rho, takes a special shape of radius R when the gas is allowed to flow freely out of this. Radius changes from R to 0 in time t. The speed of this one, okay, so now we can see one thing, that the surface energy which it has, okay, that will be like the energy required to form the bubble here, to form the balloon, is the W is equal to S into delta A. And S is the surface tension, delta is the change in surface area. So which we can say is like at an instant, if we write, because see in the question we need to find the speed and the R relation. Okay, so at an instant, if we say at an instant when the radius is small r, so surface energy required is W equal to S into 4 pi R square is equal to, this energy will be converted into kinetic energy, right, which is coming that speed only. So now from here S into 4 pi R square is equal to half m is like the mass of the gas present in that case, so rho into 4 by 3 pi R cube into V square. So from here the V square is inversely proportional to R, which that we need to see that relation between V and R. So V is directly proportional to R to the power minus 1 by 2. So from here that A value is minus 1 by 2, that is for sure. Now we need to find the time. Okay, for that we just see that entire energy is gone out. Okay, so that work done, the surface energy will be S into 4 pi R square this time and half mv square. Okay, now here we need to see that the mass, the mass of the gas which is like gone out. Okay, so that we can see like, so S into 4 pi R square and mass again same 4 by 3 pi capital R cube, that we can write into V square. Okay, we need to write A and capital R both. Okay, anyway, so let's see here what I'm doing here. Let's because in the time taken we need capital A and capital R both, and A is again like that area which is like the smaller one. Okay, so I'll just wait a second. So okay, so here like I just 1 second write it again, because I need to write this in terms of small r at an instant again. Then we'll see like if there's a possibility of integration. The rho into 4 by 3 pi r cube, my mistake, into v square. Okay, now from up, see now we just need the relation. Okay, so constant all if we don't care, so v square is directly proportional to S by rho r. Okay, so v is directly proportional to root over S by rho r. Now v is the speed which is like coming out. Okay, so that changes to dr by dt. So dt is directly proportional to rho by S, then root r dr. Now we integrate here, so time is directly proportional to rho by S, r to power 3 by 2, limit r to 0, like whatever it is. So we just like focus on the variables r to power 3 by 2. Up this is the time period which we are getting, but in the question if you see there's we have area also, and area we need to consider. So we can see the continuity equation that a v1, okay, that speed through the orifice is v1 is equal to the area of this one, okay, that sphere, which is 4 pi r square, 4 pi capital R square into v only, let's say. Okay, so here we just need to substitute that r square is equal to a v1 by v, directly proportional again. So for that I need to multiply and divide with r square, so that upper term becomes r to power 7 by 2, and this r square is directly proportional to a. Okay, unit wise like also we can do this question. Okay, this one I just like derived it. There's another method like which you can use, like using the dimension formula. You just write the unit of each variable and just like can solve. So T is directly proportional to root rho by S, directly proportional to 7 by 2 divided by R square, which is directly proportional to A. Now this is the relation, and with this one you can see that option 1 is correct. Okay, we just match the option along with this. Okay, this is one thing. Another thing, you can do the dimensional formula. Okay, just equate the units and directly you can get it. Okay, so hope you understood. Let's move to the next question. Okay, this is a vertical circular motion question. A bob of heavy mass M is suspended by a light string of length L. The bob is given a horizontal velocity V0. If string gets slack at point P, make an angle theta from the horizon. The ratio of the speed V of the bob at point P to its initial point V. Okay, so in vertical circular motion, we know the formula Vp square. The velocity at any point P makes theta angle with the vertical is equal to Va square minus 2gl1 minus cos theta. Okay, so if it is Va, here it is Vb, this angle is theta, so this is the formula. But here you can see the theta is like 90 plus theta, that total angle. No, this one we need to find. So in place of theta, I'll put the 90 plus theta, so which makes 1 plus sine theta. Okay, so this is the formula. The speed at P point. Okay. Okay, now we need to find the Va value, so that we can do here at P point. Let's see. At P point, we know that the string becomes slack. So at P point, so this is the P point, this is theta. So if we write that equation of net force, T mg, this is 90 minus theta. So T plus mg sine theta equal to m Vp square by L. At this tension is 0, so Vp square is equal to GL sine theta. Now put this value here. So Va square, which is V0 square, equal to GL sine theta plus 2GL plus 2GL sine theta. So V0 square is equal to 2GL plus 3GL sine theta, and V0 square equal to GL, if we take common, to 2 plus 3 sine theta. Now just take the common of these two. So Vp square by, just 1 second, Vp square by V0 square equal to, it is coming as sine theta by 2 plus 3 sine theta. Now if we take a square root, Vp by Vo, root over sine theta by 2 plus 3 sine theta. Okay, so that's the option 2. So this is the correct answer. So I hope you understood. Let's move to the next question. This question is based on the error, which is like straightforward. Okay, you just need to write the error here. So 3 dA by A. Okay, I'm just writing directly. I hope all you know the formula. dC by C plus 1 by 2 d of T by D. Okay. Sure. So dP by P is equal to 3 into A is the percentage 1 plus 2 into 3 plus 1 into 2 plus 1 by 2 into 4. So just solve it, multiply by 100, it's already there, 3 plus 6 plus 2 plus 2. So 4, 3, 7 plus 6, 13%. So option 1 is correct. Let's move to the next question. Okay, next question, which is based on the angular momentum conservation, because the size of that planet is changing and we need to find its time period. The angular momentum will be conserved, which means omega 1 r1 square equal to omega 2 r2 square. Now omega 1 is 2 pi by 27 days into r1 square equal to 2 pi by time period. R2 is given as expand twice its present radius, which is 4 r1 square. So from here the t will be equal to 27 into 4, which makes 108 days. Okay, so easy question. So option 2 is the correct answer. Let's move to the next question. Question number 33, based on the gravitation, because here we need to use that relation between time period and the semi-major axis. So according to Kepler's third law, what is the Kepler's third law? T square is directly proportional to a to the power 3. So here t1 square by t2 square is equal to a1 cube by a2 cube. That time period of Martian year, okay, is given 687 days. The t2 is equal to a1. Okay, it says that the radius of Martian orbit around the sun is 4 times. So a1 is like 4 times a2 by a2 to power 3 by 2. Okay, I took the square root also. So 4 to the power 3 by 2 is 8 only. So 687 by 8. When we'll solve this one, we'll get 88 days. Earth days. Okay. So option 3 is the correct one. Hope you understood. Let's move to the next question. Okay, question number 34. Based on that resistance, current electricity, a wire of resistance R is cut into 8 equal pieces. So each will have R by 8 resistance. From these pieces, 2 equivalent resistances are made by adding 4 of these together in parallel. Okay, so 2 resistors are formed by connecting these 4 pieces in parallel. So that means the R by 8, R by 8, R by 8, R by 8. So it makes R by 32. 1/4 of that one resistance, right? So R by 32 and this same setup we have like 2 forms to R by 32. Now these 2 resistors are connected in series. So R by 32 are connected in series. So what will the R equivalent? 2R by 32, which means R by 16. And that is the answer. Again, an easy question from the current electricity. Hope you understood. Let's move to the next question. Okay, question number 35 from the modern physics, right? De Broglie wavelength. Okay. So a photon and an electron mass m have the same energy. The ratio of their De Broglie wavelength is, okay, so photon energy, which we write hc by lambda, which is like pc, okay, and the energy of the electron is E dash equal to half mv square, and that wavelength, okay, wavelength of photon is h by p is equal to hc by E, and wavelength of the electron is h by and V can be written as h by root over 2m E dash. Now it says that they have same energy, so E and E dash are same. So instead of E dash, I'll write E only. Now I'll take the ratio. So lambda P by lambda E is equal to hc by E times h by 2m E. Mm cancel here, and this root is cancelled. So what do you have? Root 2m by sir, 1 second. Okay, so yeah, so 2m by E into C. So that is option number 1. Okay, so that is the ratio of the wavelength lambda. So option 1 is correct. So hope you understood. Let's move to the next question. Okay, next question number 36, which is based on the moment of inertia. Okay, so for that, to solve this question, first we need to know the moment of inertia of a solid sphere passing through its axis is 2 by 5 mr square, and like moment of inertia of its tangent is 7 by 5 mr square. So that's what we are going to use here. It's asking the ratio moment of inertia of the smaller sphere to that of the rest part of the sphere. So moment of inertia of the rest part will be moment of inertia of the bigger one minus moment of inertia of the smaller one, right? So I dash equal to IB is moment of inertia for bigger sphere. This about the y-axis. The y-axis is passing through the center. The formula is 2 by 5. Its mass rho into 4 by 3 pi 8 r cube, because radius is 2r. So 2 by 5 m r square, so 4r square, minus the smaller one. For the smaller one, this y-axis is the tangent. So tangent wala aayega 7 by 5. Its mass 4 by 3 pi. Its radius is r cube into r square. Now just solve it, and we'll be getting rho into 4 by 3 pi r to the power 5, 64 by 5 minus 7 by 5, which is rho 4 by 3 pi r to the power 5 into 57 by 5. Now take the ratio I dash by I. Yes, rho into 4 by 3 pi r to the power 5 into 57 by 5 divided by the smaller one 7 by 5 rho into 4 by 3 pi r to the power 5. ये तो कैंसिल हो गया, 5 कैंसिल, तो 57 by 7. So this is the moment of inertia of the remaining to the smaller one, but I think they are asking that ratio of the moment of the smaller to the rest part, तो reverse करना है, तो smaller to I dash, so 7 by 57 is the answer. So the first option is correct. So hope you understood. Let's move to the next question. This question number 37 is based on the electromagnetic waves, where we know like the magnetic field components, electric field components are always perpendicular to each other. Let's see the question now. The speed is c by 100. The magnetic field 9 into 10 minus 4 perpendicular to its direction of motion. Wish to apply electric field. Okay, you can see here with the magnetic electric field, so the electron does not deflect from its path. Okay, so this is like a question from the magnetism only, है ना? Magnetism chapter, not wave, right? So where we apply the formula of the velocity reflector, velocity selector, sorry. The V is equal to E by B. Okay, so this is the formula which we are going to use here. E is equal to B into V. So B is 9 into 10 to the power minus 4 into V is C by 100. So 27 into 10 to the power minus C is 3 into 10 to the power 8, 4, 2. So this is the electric field, 27 into 10 to the power 2 volt per meter. And we know like the electric field has to be perpendicular to this V magnetic field, right? If you remember that velocity selector, okay, the electric force and the magnetic force should be opposite to each other. So we take the magnetic field into the plane. This is the charged particle which has to move in the same direction without any deflection. So the magnetic force is upward direction, the electric force has to be downward, and which is possible only when the electric field is downward. So you can see the direction of electric field, which is downward, minus j cap, and magnetic field is into the plane, minus k cap. So both are perpendicular. So that option 4 is correct. They are perpendicular, and magnitude of electric field is 27 10 to the power 2 volt per meter. So hope you understood. Let's move to the next question. Okay, yeah, this question is from the electromagnetic waves, where you can see that electric component and magnetic component. So again, electric component, magnetic component has to be perpendicular. So if E is in Z direction, to B in Z direction is not possible. Okay, it could be Y, it could be, okay, and if the wave is moving in H direction, to be in H direction is also not possible. So only 2 and 3 options are left. And now we just need to find the magnetic field, the peak value. So again, the formula is same, that E is equal to B into C. We are going to use, so E is equal to speed of the light, है ना? Okay, so we need to find magnetic field. So E by C, E is 60 divided by 3 into 10 to the power 8. So B is equal to 20 into 10 to the power minus 8, yeah, 2 into 10 to the power minus 7. So that is the like peak value, and the equation is going to be same only. Okay, so that's it here. So let's answer option 3. So hope you understood. Let's move to the next question. Question number 39, based on the gravitational force chapter. The body weighs 48 Newton on the surface of the earth, experienced by the body due to the earth at its height equal to 1/3 of the radius. So that the variation of g in height 1 plus h by r whole square. So gh is equal to gs, height is r by 3 whole square. So it makes gs 1 plus 1 by 3, 4 by 3, 69. Now we just need to find the weight, so we'll multiply with mass. So this is the mgs, the weight on the surface. This is the weight on the height which we need to find. So 9 by 16 into 48, 27 Newton. The fourth option is correct answer. So hope you understood. Let's move to the next question. Question number 40 is on the wave optics chapter, related to the Brewster angle. So it says that the Brewster angle with the refractive index 1.73 is nothing but root 3 only, right? So Brewster angle is tan inverse 1.73, that gives you root 3. Sorry, this is root 3, so that gives you 60 degree. So that means that 60 degree angle, the reflected ray according to the Brewster angle, that Brewster theory, at this angle the reflected ray will be completely polarized and the refracted ray is partially polarized. Okay, now let's see the options. Not the first one, transmitted light is completely, not the second one, reflected light completely polarized, and then yes, the third option is correct. The reflected light is completely polarized and the angle of reflection is close to 60 degree. Means that's how the diagram is. If angle of incidence 60 degree, this will be 60 degree, this will be 30 degree, and this is 90 degree. So it's completely polarized, partially polarized. Okay, so option 3 is correct one. Hope you understood. Let's move to the next question. Okay, next question from the current electricity. We need to find the current through the branch CD now. So C and D, okay, they are connected with the connecting wire, so both are at same voltage. So first we'll try to find out the current coming from the 50 volt battery. So for that we need to find the R equivalent. So 3 and 1, so 3 by 4 and it is like 4 by 3. This is V, this is 50 volt, this is like I assumed as 0. So current is equal to 50 by this, just add them up, so it will be like 25 by 12. So 24 ampere current will be flowing here. Now when 24 ampere current is flowing, now we can like simply find the V value. So V minus 0 equal to 24 into 4 by 3, 32. So that means this is 32, this is 32, here 50, here 50, here 0, here 0. Now we can find the current. Okay, so current in this 1 ohm, 50 minus 32, 18 ampere in this one, remaining 6 ampere in this one. Now 32 minus 0 by 2, 16 here and then 8 here. So that means you can see here 18 becomes 16, that means 2 ampere were gone into this direction. So CD current, how much is it? 2 ampere, and it's flowing from C to D. Okay, that could be like the question, the direction, but they are asking the magnitude only, so it is 2 ampere. Okay, so hope you understood. Let's move to the next question. Okay, this question is based on the capacitance chapter, okay, with the dielectric. So you can, there's a parallel plate capacitor separated by D, two slabs of different dielectrics, K1 by K2, 3D by 8 and D by 2 is nothing but 4D by 8, makes 7D by 8. That means the capacitor is not fully filled. So this is 3D by 8. So there's some region where that only air or vacuum is left, and this is 4D by 8, correct? So now here we have 3 capacitors. Those are in series. So 1 by C dash equal to 1 by C1 plus 1 by C2 plus 1 by C3. Now I'll just value C formula is epsilon naught A by D. So this one is D by 8 only, okay. So D by 8 by epsilon naught A plus 3D by 8 by K1 epsilon naught A. This is K1, this is K2 plus 4D by 8 divided by K2 epsilon naught A. So 1 by C dash, okay, and now they are saying that due to this capacitance becomes 2 times larger than when there is nothing between the plates. So that means there is a capacitance C naught, okay, when there is nothing between them, okay, that is epsilon naught A by D, and this C dash is 2 C naught, that is given. So I'll put the value of 2 C naught to 2 C naught epsilon naught A by D, and here if we'll take some like D by 8 epsilon naught A common, and what is left here in the bracket? So 1 plus 1 by 3 by k1 plus 4 by k2. Okay, k1 k2 relation is also given. The k1 by k2 is 1.25 100 5 by 4. We need to find k1 value, right? So we'll substitute k2. So k2 can be written as 4k1 by 5. So we'll put this value here. This is cancelled. 4. So 4 is equal to 1 plus 3 by k1 plus 4 by k2 is 4k1 by 5. So 5 by k1. So 1 plus 3 by k1 plus 5 by k1 is 1 plus 8 by k1. So 3 is equal to 8 by k1. So k1 is equal to 8 by 3, which is 2.66. So that's the option 3. Okay, and that is the answer. So hope you understood. Let's move to the next question. Question number 43, which is on that error measurement. Okay, and we have to use here vernier scale. Okay, so in the question it says that suppose it's 10 vernier scale division are equal to 9 main scale division and least division ms is 0.1 centimeter. So with these three things, like, we can find the least count of the vernier scale, and that will come 0.01 centimeter. That all of you know how does it come. Okay, that's the basic process. Once we have a least count, now we can find the reading. So for reading it says that main scale diameter is 5 centimeter, so it is going to be 5 centimeter plus number of coincident division 8 into least count. So reading is coming as like capital R for reading. Okay, 5.08 centimeter. Okay, this is the reading when there's nothing said about the zero error. But if you see the line, the zero of the vernier scale is at h equal to 0.1 centimeter. The jaws of vernier calipers are closed, which means if it is 0, 1, 2, 3, 4, 5, this is the main scale, and vernier scale 0 is here. Okay, so zero error, so that means it has a positive zero error. First of all, positive zero error, which where that zero of vernier scale is right to zero of main scale. And how much is it? So this distance we need to find from the zero of main scale where the zero of vernier scale lies. So this distance is nothing but 0.1 centimeter, that is given. So positive zero error we have, so we just need to if it is a positive zero error, then we need to subtract the final reading. The final reading is equal to 5.08 minus 0.1, which makes 4.9 4.98 centimeter. Okay, and that is the answer of option number 1. So hope you understood. Let's move to the next question. Okay, question number 44, which is based on that magnetic moment of coils. The formula is m equal to I into A. So that's what we are going to use. 2 ampere current is flowing through two different smaller circular coils having ratio 1:2 the ratio of their respective magnetic moments. So m1 by m2, they have same current, so a1 by a2, which is r1 square by r2 square. So m1 by m2 is nothing but 1 by 4. That's it. Straightforward, very easy question. So option 3 is correct one. Okay, so hope you understood. Let's move to the next question. Okay, so this is the last question of this NEET 2025, and this question I personally feel like this is a tough question. Okay, if we keep NEET level, okay, in the mind. Okay, so but anyway, this was the only question which I found difficult in the paper, that very much difficult. Okay, as per the NEET level students. Okay, so let's start this question, the last question of this NEET 2025. Okay, this one, the question says there's a water surface we have. Okay, so this water surface is made at different angle at different point of time, right? Different places. This is so now just to get the relation. Okay, we need to apply the surface tension, because there's a surface tension acting each and every point, and we know that the surface tension will be acting like the force and not the tangential. So what I'll do here is I'll take an element on this surface here. Okay, so the element is like gonna be this one. Okay, this is the element. Clear? And it says that the very wide, the length of this container in the z direction is very long. Okay, so that also we have to take something into consideration. So now if I draw this diagram, this element somewhat like this, the element, first I need to define the position of the element. So at h distance, this distance is dx. Similarly, this is y and this is dy, and it's made some angle here. Let's say this is theta. So you can see here at different point of time, first of all, at different point on the surface, the force will be different, right? So here, okay, and the surface tension, we know it is like pulling force only. So at this moment the force will be in this direction, and it made some angle here. Here, let's say if it is make theta angle, that means here it will be making theta plus d theta. Okay, so these are two components, fx and fy. On the other side there will be again like tangential force here, f dash. So two components, fx dash, fy dash. Now we need to write the surface tension, so we'll just consider the net vertical forces, and these are the forces which is acting. Now if I assume that this length is capital small d, let's say, not capital D, let's small d, variable only. So this fy and this fy dash are acting perpendicular to this length, and this is the we can say the width, okay, of this leg, which is like very wide, very long. So this fy is acting perpendicular to this t here. So the surface tension, the formula is s equal to f by l, right? So now f is equal to s into l, so that we can say here now, right? So that's what we are going to do here. So we'll balance the forces to fy minus fy dash equal to mg, dmg, the mass of the element. So this is the equation which we are going to use here. So fy is equal to s into, okay, components, let's take the component first. What is fy? So it is f sine theta plus d theta, and this one is f dash sine theta is equal to dm into g. And what is force here? So it will be s into d. So sine theta plus d theta, s is the surface tension, minus s into d sine theta is equal to dm. Dm will be the mass of the element. So the element which we took here, this whole element is balanced, the mass of this entire liquid which is present here, which is balanced by dmg, like that. So that is like density is mass equal to density into volume. Volume is like what is the volume here? Y into dx into d into g. Okay, so density into the volume, this is the volume into g. Okay, so y is the height, dx is the width, and small d is the like breadth, we can say. So d cancelled. Now, and this thing like the thetas are very small here everywhere. Okay, and this approximation we can do. So sine theta plus d theta becomes theta only. So theta plus d theta minus s I took common, theta is equal to rho y g into dx. It's cancel here. So d theta by dx is equal to rho y g by s. Okay, so this theta by dx we need to substitute. For that we can say here the sine theta, right? So in this one dy by dx, right, the given equation dy by dx is sine theta, right? Now we can differentiate here because we need to substitute with d2y by dx square. So d2y by dx square is equal to cos theta d theta by dx. So this d theta by dx is, and theta is small, so cos theta value is 1. No, the theta is small, Then sin theta is already given, which is theta, and cos theta almost 1. So 1 into d theta is rho g by s into y. Okay, and that is the fourth option which we have here. Okay, so hope you understood. And so based on, so this is the only critical point where we just need to think is the surface tension, the forces will not be same here, and we just need to balance this one, because the same thing we do in the capillary rise also, you know, where we like balance the forces. And if you just think about the capillary rise, so same kind of thing we do, but there's only like we have one surface, okay, and the theta is changing continuously, right? So that's why we need to, because the force direction, theta direction, everything is changing, right? That's why we have to go by this method. So this was, so with this question, the whole paper NEET 2025 is over, and I'm sure like whoever is watching this video will find this whole video very helpful. Okay, and if you appreciate this then, so please do comment, okay, and the like obviously. Okay, so that's just for a motivation, right? Okay, so that's all from my side. Thank you all for watching. Thank you.